Okay, number 55. Hope you're getting the hang of this. If you draw these and think about them, they're not too hard, but they kind of make sense. And we've done a lot of these where we can find all the trigonometric functions. Remember, we did some earlier where we had to find the 6 trigonometric functions of all the angles. I made a little template, so this isn't that bad. All right, so we want the secant. All right, now remember, I'll just write it over here just to kind of help me out. Remember, the secant of an angle is equal to 1 over the cosine, right? The secant is 1 over the cosine. And the cosine is the what? Adjacent over the hypotenuse. So the secant is the hypotenuse over the adjacent. So that's the secant. So that might help us to remember that, okay? So the secant is 1 over the cosine. The cosine is adjacent over the hypotenuse. So the secant is, just flip that, hypotenuse over the adjacent. So that's what we're looking for. Once we find, this we're going to be looking for this angle here. So let's draw a sketch, and this is going to be this inverse sine. This is the angle whose sine is negative 1/4. If it's negative 1/4, what quadrant would it be in? Well, it's going to be negative, so it's going to be in the 4th quadrant. That's where the sine is negative. And this is the angle whose sine is negative 1/4. So I'll draw it right down over here. And this is my angle theta. And once I have this triangle, I can figure out all the 6 trigonometric functions for theta. All right? So there we go. So it's negative 1 over 4. Remember, the sine is the what? The opposite over the hypotenuse. So the opposite, this is the opposite, and this is the hypotenuse. And that's going to be 1 over, and this is the adjacent, of course. And the opposite is going to be negative 1 over the hypotenuse, which is 4. Okay, so I'll write it like that. Now, does that triangle, if we look at theta, is theta the angle whose sine, is theta the angle whose sine, that's what this is, the angle whose sine is negative 1/4. Well, if this is theta, the sine is the opposite over the hypotenuse, that's negative 1/4, so that looks okay. So this is a good go for theta. And I want to find the secant of theta, the secant of this. So I'm going to find the secant of this, which is going to be the hypotenuse over the adjacent, so I've got to figure out what that's going to be. Okay, so I have to use our Pythagorean theorem, and I'll say a squared plus negative 1 squared equals 4 squared. A squared plus 1 equals 16. So a squared equals 15 if I subtract 1, so a equals the square root of 15. So there we go. And remember, the secant, what we're looking for, is going to be equal to the hypotenuse over the adjacent. So that's going to be equal to 4 over the square root of 15. All right? And we're going to probably have to rationalize that for this book. I mean, that's fine for me, but if we multiply the top and the bottom by the square root of 15, we've got 4 times the square root of 15 divided by 15. All right, we rationalize that. Multiply the top and the bottom by the square root of 15. And the square root of 15 on the top. Square root of 15 times square root of 15 is 15. Okay? All right, let's try number 57. I'll double check, make sure that I copy these down right. Okay, that looks good. So this is the angle whose cosine is negative 1/3. Now, where is the cosine negative? Remember, the inverse cosine is going to be in what quadrants? 1 and 2, so it's going to be negative in the 2nd quadrant. So I'm going to be drawing this in the 2nd quadrant. I'll draw over here, so I have a little room here. And there we go. So that's where my angle is going to be. This will be my theta. And this is where the cosine is negative. It's positive, negative. Remember, the inverse cosine occupies these 2 quadrants, or the range of the angles is between 0 and pi. So I'm in those 2 quadrants, and this is where it's negative in the 2nd quadrant. And it says that is going to be, and remember the cosine is going to be what? The adjacent over the hypotenuse. And here's your adjacent. Here's your hypotenuse, and this is the opposite, of course. And we're going to have the tangent, and the tangent will be the opposite over the adjacent, so I'll need both these sides. Let's not get ahead of ourselves. Okay, what is the adjacent? It's -1, so I would call this -1, and that makes sense because it's going in the negative direction. And the hypotenuse is 3. So let's take a look at this angle. What's the cosine of this angle? -1/3. So there we go. So that's theta. Theta is the angle whose cosine is -1/3, so this is theta. This is the angle, so this is an angle whose cosine is -1/3, and definitely this is the cosine of this angle is -1/3, so we're good to go. So we have to find the opposite, so we'll say that O squared plus -1 squared equals 3 squared. O squared plus 1 equals, and 3 squared is what? 9. So O squared equals 8. So O equals the square root of 8. And that's 4 times 2, so that's 2 times the square root of 2. And that's O. Okay. So there we go. Don't forget when you're filling these in, your SIGNs, this is a negative. So when we take the tangent, what's the tangent of theta? The tangent of theta is the opposite over the adjacent. And that's just going to be a negative over there, so I'll just put that over -1, so that's just going to be -2 square roots of 2. Okay? So hopefully that makes sense. And then 59. The cosecant, now this is another tricky one, so let's kind of jot this down over here. Remember the cosecant is 1 over the sine, or the flip-flop of the sine, or flip it, inverted I should say, be more mathematical. So the inverse of the sine is the opposite of the hypotenuse, so it's the hypotenuse over the opposite. Okay? Opposite over hypotenuse, hypotenuse over the opposite, so that's what I'm looking for. So let's draw our sketch here, and this is again going to be cosine negative, so it's going to be again in the second quadrant like this one. I'll be running out of room here for my last problem of this type. And these don't have to be to scale. This is just, we're going to put the values in. And the cosine is going to be negative. Remember, the cosine is the adjacent, just like 57. Adjacent over hypotenuse. This is the adjacent. This is the hypotenuse. This is the opposite. And in this case, the adjacent is going to be negative the square root of 3. And the negative side's got to be there because the hypotenuse is always positive, so that's going to be 2. And the square root of 3 is about 1.7, so it's definitely smaller than the hypotenuse, which is always the longest leg of the right triangle. Okay? So what we're looking for is we want to find the hypotenuse over the opposite, so we have to figure out what the opposite is going to be. So I have to use Pythagorean theorem. And that's not too bad because that's negative the square root of 3 squared plus O squared equals 2 squared. That's your hypotenuse. Okay? So that's going to be just 3. Square root of 3 squared is 3. And a negative times a negative is positive. Plus O squared equals 4. If I subtract 3 from both sides, I get O squared equals 1. So O equals 1. So it's just 1. So that goes over here. And remember, it's going to be the hypotenuse over the opposite, because I want the cosecant. So it's going to be 2 over 1 or just 2. That was nice. Okay. And then the last one. Take a look at this. Alrighty. And 61. Okay. Okay, kind of bear with me. I'm kind of crowded in here a little bit because I did 49 here. Give myself enough room. So let's see if I can fit this in. And this is the tangent. Now remember, the tangent is going to be like the sine. It's going to be the first and the fourth quadrant. All right? I think I'll draw my sketch over here so you can see this one. So this is actually for 61. So we'll draw a little arrow down here. And this will be the sketch because I've got more room down here. So I'm going to be in which quadrant? I'm going to be in the fourth quadrant because remember, the inverse tangent occupies the first and the fourth quadrant because it's negative pi over 2 to pi over 2 like the sine, except it's open intervals rather than closed. All right, so it occupies those quadrants, and it's going to be negative in the fourth quadrant because they're all positive in the first. So I'm going to deal with the fourth quadrant. So let me draw my angle over here. And what does it say? This is the tangent. And what's the tangent? The tangent is going to be the opposite over the adjacent. And this is my angle theta here. All these were theta. Okay. And it says that's going to be, oh, that's the wrong one. Okay. Better look up here. Negative, so the negative's got to go, it's not going to, well, if I look in this quadrant, where will the negative go? Well, the negative's got to go here, not here. So that's going to be, opposite is negative 2 over 3. You can see that because the 3 is going to the right and the 2 is going down. Okay? So let's double check this. Look at theta and ask yourself, what's the tangent of theta? Opposite over the adjacent, which is negative 2/3, so that jives. Okay? So we want to find out what the tangent, what the cosine of that is, and the cosine is going to be the adjacent over the hypotenuse. So that's what I'm looking for. Keep looking over here. I got to be careful. Okay? So I want the cosine of that. So I need the adjacent I've got, and I need the hypotenuse. So how can I find that? I can use the Pythagorean theorem. 3 squared plus negative 2 squared equals h squared. So that's going to be 3 squared is 9, and 2 squared is 4 equals h squared. So 13 equals h squared. So the square root of 13 equals h. Okay, so now I got h as the square root of 13. I hope you can see that. And remember, I want this is theta. This is theta over here. All right. So if I look at theta, what's the cosine? That's the adjacent over the hypotenuse. So the adjacent over the hypotenuse will be 3 over the square root of 13. And I'll probably have to rationalize that, so I'll multiply the top and the bottom by the square root of 13. So I'll have 3 times the square root of 13 all over the square root of 13 times the square root of 13, which is 13. So there you go. So this is the sketch for this, all right? Okay, so I think you can see how your work. There's just a lot of little sketches you have to draw, and it's not bad to be able to do this. Okay? So I'll have to see all the sketches on your homework. Make sure that's all done correctly.